Hello everyone, welcome to my presentation entitled Favorable Steel Structure Using High-Strength Steels. My name is Fengyan Gong from Hochtief, Germany. In order to overcome special obstacles in the wide use of HSS in building structures, a European research project Strobel was carried out. The project developed cost-efficient design rules for HSS structures that would be adopted in the Eurocode in future. As part of this project, Hochtief Engineering has developed a calculation software for BIM with HSS. Today, I will show you how the online design tool is working. After presenting the results of parametric study using the online design tool, I will highlight some case study. Finally, some recommendations will be given. Based on Hochtief Web Tool, SCI developed an online tool for the design and optimization for BIM. The software is available in the internet free for charge. This is the main page for the design tool. Just click here. We can reach the program, and a simple supported beam is considered under different kinds of loads. We can choose standard or fabricated section, and for a standard section, we have a large choice for hot rod section. And now we just consider fabricated welded profile. You can give the parametric for this cross section, and we can choose different steel grade for the flange and web. Now let us calculate this case. And you can find a summary of these calculation results. Just scroll down, you can find more information about this calculation. And using this tool, we can also do some optimization. Due to the time limit, I will pass this part. Now, I would like to summarize what we can do with the online design tool. The simply supported beam under point loads and line loads, as well as the axial force, can be considered with the steel grades from S235 to S619. The cross-section classes 1 to 4 of standard profiles and welded plate as well as hybrid girders can be taken into account. The optimization for the cross-section can be done in order to find the latest section weight, while other criteria such as deflection limit, lateral torsional buckling, and section height can be accounted. Now let us jump to the parametric study. For all the kinds of cross-section, that means hot rod sections and welded plate or hybrid girder, the parametric study has been done with a simple beam under contribution load from 2.5 to 50 kilonewtons per meter. The span has also varied in a big range from 2.5 to 20 meters. The calculations with the different steel grades have been performed with and without considering deflection limit. This slide shows the results for hard road section without consideration of deflection limit and lateral torsional buckling. The horizontal axis denotes the span and the vertical axis the weight. We can see the benefit of S460 with 40% weight reduction comparing to S235. The situation will be changed if a lateral torsional buckling is considered. In this case, there is normal advantage for S460 over S355. The weight reduction for S460 compared to S235 can be reached using current Eurocode up to 20%. If the global deflection limit must be considered with air over 300, there is no benefit for HSS. Now let us focus on a beam with a large span of 20 meters with a total line load of 40 kilonewtons per meter. In this case, the load ratio of died to live load is 1. Again, the analysis is conducted for different kinds of cross sections. The welded plate girder and welded hybrid girder. This diagram shows that with the standard profile, just the 11% weight reduction can be reached with S460, while 35 by the welded plate. Using S619, the weight can be decreased up to 47 by welded plate girder and 44 by hybrid girder with S355 in the web. It is clear that welded hybrid sections are very effective. From the parametric study, we can derive that more benefit by using HSS can be gained if the following constructive measures are taken. For example, lateral constraints on the up flange and reducing the deflection limit through precamber of beam for tight load. You can see more information in the SCI document. The flow system of an industrial building that is currently under construction consists of a 25 centimeters thick concrete slab resting on 7 secondary beams that in turn are supported by 2 main girders. The rest of the floor system is 7.2 in wide and 7.5 in length. As shown in this figure, the beams are chosen as a whole road section size IPE 500 of S235, while the main girder are built as welded profile from S355. The first table shows the optimization results for main girder with unsymmetrical profile because that profile are highly effective when a lateral torsional buckling has to be considered. In this example, the sieve weight of the girder in S460 could be reduced by up to 31% in comparison with a symmetrical normal plate girder in S355. Using online design tool, weight reduction for secondary beam can be reached up to by 27% and 40% compared to S235 if S460 or S355 are used, respectively. Finally, we can draw the conclusions and give the recommendations for using HSS as follows. Especially for large span and high loading, weighted plate section with HSS are highly effective. More benefit for weighted profiles than standard profile with HSS. Large girder heights and smaller plate thickness are effective geometries. Hybrid section with low strength of the weight are very effective. As I mentioned before, generally air lateral constraints on the up flange are recommended. Deflection limit has to be reduced. Thank you very much for your attention.